We are live now.
Thank you. So let me welcome all of you to the inaugural function of R&D Showcase 2021 of IIIT Hyderabad. I'm CV Jawahar, Dean of Research at IIIT Hyderabad. R&D Showcase is an event which IIIT has been organizing for many years, nearly 20 years, for connecting our research to the people around. Every year, the research at IIIT is open to the public to come and see for 2 days. And we have been seeing lots of students from nearby colleges, schools coming and seeing. Lot of working professionals, industrial researchers, collaborators, friends, startups, lot of people visiting us and knowing what we do and building relationships over cup of coffee, seeing a demo, casual interactions. However, unfortunately, this year we have to do this in online mode. All of us know we have no other solution at this stage. In fact, to be precise, so last year we were in the middle of preparation of R&D Showcase, and possibly we had to cancel, and we were thinking again and again whether it is worth to cancel R&D Showcase at that stage. Is COVID going to be that big at that stage? We are not sure, but exactly 1 year back we cancelled, and possibly that was first major cancellation that we had to do in IIIT Hyderabad before we all went to the online mode for a year. So this year, the R&D Showcase is in an online mode, and we take the advantage of that by getting an eminent speaker, Professor Ashok Jhunjhunwala, to speak on this occasion. We also have a set of demos, presentations on the research and activities at IIIT Hyderabad in an online mode. Thanks to the effort of Professor Ramesh Loganathan, Professor Aftab Hussain, and the outreach team. So we have an online R&D showcase, which is trying to meet the expectation that has been set by the R&D showcase in the past. So this inaugural event is for an hour plus, and after that, the online presentations and research showcase will continue. I invite all of you to see and interact with the participants and interact with the institute, the associated students, faculty, researchers, and various stakeholders. So now I will invite Professor P.J. Narayan, Director of IIIT Hyderabad, to introduce IIIT Hyderabad and the event.
Thank you, Jawahar. Welcome from my side to everyone to the R&D, the online version of R&D Showcase. It's an important event for us. I will briefly talk about the institute with a few slides. So let me just share my screen first. A brief introduction into IIIT Hyderabad is being planned. So IIIT Hyderabad, on a normal year, you would have been here on this campus, seeing the beautiful campus. Instead, this year we have to show it. I have to show it to you through this picture. So, as an institution, we started in 1998, started by the state government, but not supported or funded by the state or any government. So, it's fully financially self-sufficient and hence administratively self-sufficient. We have a name IT in the institute's name, so we have information technology focus, but we are not only developing the technology, but also many application areas where IT or computing can play a major role. That's our focus. And with institute has very strong research orientation from the beginning. We want to be a research institution that also teaches. And one particularly interesting aspect is of undergraduate participation in research. That has been an early objective of the institute's functioning. This has resulted in very high research impact from both the institute and its alumni after leaving here. And one of the outcomes of this institution starting in 98 and doing well early is MHRD adopted this model and created 20 PPP IIITs across the country, starting with Guwahati to Kerala to Gujarat, everywhere. So we think that's an affirmation of the model at which this was created. So in terms of academic programs, we are a technology, IT institution. The undergraduate programs are currently only in computer science and engineering and electronics and communication engineering, CSE and ECE. However, being a research-oriented institution, we have a 5-year dual degree program where bachelor's and master's by research, which is a thesis-based master's, is in computer science and ECE definitely, but also transdisciplinary program where the BTech is in computer science and the master's, the research-based master's could be in one of the domain areas. 3 are currently active: computational natural sciences, computational linguistics, computational human sciences or humanities. We have many PG programs, a few PG programs in computer science, computer information security, and computer structural engineering. This year, in 2021, we are starting a new PG program on software product design and management. It's a unique program which has design, which has business, and of course the software engineering and computer science as part of this. And we have research-based masters, thesis-oriented MS by research, and PhD in all the areas that mentioned above, plus some more like cognitive science, spatial informatics, and so on. We also been running several advanced certificate programs or executive education programs. One in AI ML and another one in blockchains has been running for 3+ years. 2 of them will start very soon, or the preliminary work has started. One in software engineering for data science and one in Internet of Things. And in terms of the research focus areas at the institute, we have many of the technology areas, starting with natural language processing or computer vision, robotics, software engineering, etc., etc. All the technology areas which are hot, where activities happening. We have groups working here. We hire actively, and we have many students here. You see also areas like earthquake engineering, building sciences. These are the areas where computing and domain meet together. Okay. Spatial informatics or computational human sciences. And we also have other kind of areas where we reach out to society, like smart cities, about which you will hear more. And there are many more. I cannot list all of them here. And we have also been consciously doing many socially oriented projects, because I think in the end, institutions should affect the society in a deep way. And especially our society, Indian society, has so many problems that can be helped with use of technology. So some examples of the socially oriented, fairly large scale projects that we have been undertaking are given here. Bahubhashak is a speech-to-speech translation system from English to Indian languages and among Indian languages. This is a project being championed by the PSA, the Principal Scientific Advisor to the Cabinet, and MIT together. It's a big project. This is a huge problem also, but we are focusing initially on educational material, how to create all the wonderful educational material available out there in English. How can we create them also in Indian languages? Another Indian language related effort we started last year is enhancing the content of wiki in Indian languages. If you look at, the English has about 6 million or 7 million pages. The best of Indian languages, Hindi has 100,000 pages, and others are below. So we are combining community effort. Wiki is a community effort. We are enthusing getting a large number of community IT professionals in Hyderabad, all around the country, but also using advanced information retrieval, search, and language tools so that we can rapidly increase content in Indian languages on Wiki. We are also creating many AI projects. One of them is creating driving data. We hear about autonomous driving all over world, or at least in the developing countries. That kind of research, there is no data available on Indian roads or Indian road conditions. And Indian driving conditions, we all know it's far more challenging than the Western ones. So we have started this project with support of Intel a couple of years ago, and there's large amount of data out there from the Indian roads, Hyderabad, Bangalore, etc. And we are starting some engagement with schools and how to enhance educational reach, outreach, effectiveness with technology. This is an activity just starting, but we have big dreams about it. We have started a living labs and smart campus leading to smart city. We will hear more about it later. We have been working on things like cool roof and how to reduce the heat problem with simple intervention, and large scale piloting or large scale experimentation going on with Hyderabad or Telangana and other cities, and many more such socially oriented efforts. For our research, we have also been ranked by different agencies. So here you see the table from csranking.org, which is a very harsh ranking system. They use only the top rated conferences to rank the institutions. So in computer science, all of computer science, we are ranked 6th in the country and maybe about 200 in the world. Whereas if you restrict to artificial intelligence and robotics, where we have great strength, we are ranked number 1 in India and maybe 100 in the world. So this is creditable, but there's a long way to go, as we see. We have not been taking part in these standard rankings consciously, but QS subject ranking has been ranking us for the last 2 years. We were placed 9th in India, or the 350 rank, band rank, which is maybe okay, but I think that again, we see the scope to move forward. But these rankings are rankings. We don't want to chase them. They should come after us. We are interested in that research impact that I talked about, some of it, especially the societally oriented, the large scale research impact. So with that, if we have started a few new efforts. In 2015, we started this Kohli Center on Intelligence System, which is an umbrella entity to enhance and accelerate the research in broad AI areas with significant endowment by TCS or TCS Foundation. And this has been working for the last 5-6 years, making a lot of waves. And we are now getting into more applied research through that. In that connection, we also have an FC Kohli Day to be celebrated on March 19th. These wonderful events. I welcome you all to come to that too. And we recently launched a new initiative called INAI. This is called Integrating AI. This is applied AI at population scale. These are things that we want to do at large scale, not just socially oriented, but also at large scale. And recently, we also been awarded a TIH, a Technology Innovation Hub, by the NMICPS program in data-driven technologies. You will again hear more about it. So applying research, taking our academic strength and applying it to problems that are really relevant to the society is one of our major focus areas going forward. So I will stop here with this brief introduction. I'll hand it back to Jawahar. Thank you.
Thank you, Professor PJN. So we will have the inaugural keynote talk by Professor Ashok Jhunjhunwala now. Professor Jhunjhunwala has been a faculty member, professor at IIT Madras from 1981, and he has been a pioneer in setting a lot of things in academia and Indian research space. So for example, how academia and industry can work together in solving problems of impact and scale was demonstrated by his pioneering effort in IIT Madras and the research park that he has conceived. He is keen on developing affordable solutions to the rural India. So he has touched many different areas. He has used his strength in electrical engineering, strong social commitment and vision, passion in building team and solving problems. And this was recognized by all the organizations in India and abroad. So he was awarded all the major awards in India, including Bhatnagar Award, Vikram Sarabhai Award, and of course the recognition of Padma Shri. So he has so all of us have benefited a lot from his effort in communication. The way we enjoy the online connections and internet today is thanks to so many of his efforts. So of late, he has been talking about renewable energy. And is it possible? And he is foreseeing the issues that we may face in the near future and what India can do differently. And this he has been preaching and practicing and demonstrating in different forms in the last many years. And he has been a principal advisor to Ministry of Power and Railways in Government of India, and connecting, trying to see how this sort of ideas can directly get connected to the people and common man. So let me request Professor Jindwala to speak, to deliver the talk.
Thank you, Jawahar. Thank you. And can you see my screen, please?
Yes, we can see your screen.
Okay. Thank you very much for inviting me, Jawahar and IIIT Hyderabad. I used to be on its board till I was moved out, and I really value IIIT Hyderabad quite a bit. You're both the previous director and the current director are good friends of mine, and in some manner really wish that this institute to become the top institute. So when he asked me, when I was asked to give this talk, I kind of readily agreed to PJN. I cannot refuse easily to PJN. And I thought about what I should speak about. Since it is the R&D showcase, I sort of said that there is a piece that we very often don't include in R&D. It has to be R&D, of course, will include innovation, but what is also very important is commercialization. And very often we do R&D, but not worry about commercialization. So I sort of said that I will try to do something which has a not just R&D, but R&D to commercialization focus. And then I went on to one step further. So what is the key work that we do in R&D and commercialization? What is the bridging? What bridges this, and where we as academia often fail is an understanding of economics. If you don't understand economics, simple economics of associated with our product, then we really cannot commercialize. So I decided to give a different kind of talk from what you will have in the rest of the 1 day, 2 day, whatever you are going to have. And I sort of said that I'm going to talk not just about technology, but economics. And I'm actually going to talk about something which I think is doable in India, very much doable in relatively short time, and extremely needed all over in India and all over the world, that we need to move towards renewable energy. Otherwise, greenhouse emissions and what is going in the world is going to get us into more and more serious trouble. Let us look at India. My talk is focused on India, and I'll look at a certain aspect of it, primarily on electricity. I don't know how many of you know that today to generate solar-based electricity in India cost between 2 rupees to 2 rupee 50 paise. It used to cost 2 rupee 50. The latest tender says 2 rupees per kilowatt hour. That is the cost of generation, total cost. People are ready to sell this energy at 2 rupees per kilowatt hour for the next 25 years. Wind-based electricity also costs 2 rupees 50 paise. And if I talk about coal-based electricity actually varies from 2 rupees 50 paise at nearly the bottom for the older plants. Newer plants with more pollution control measure is at 4 rupees per kilowatt hour. These are the costs in India. If I use oil or gas-based plant, it goes from 12 rupees, 16 rupees, even higher, 20 rupees per kilowatt hour. So the natural question is, since coal is not good for environment and solar and wind are good for environment, and the cost is now lower, I'll say lower because coal today, the new coal plants are 4 rupees. What prevents us moving completely to solar and wind? The first question is that do we have enough solar and wind? can we generate all the power or most of the power from solar and wind? Now, I will come towards it in the end, but we have plenty of solar and wind. Take that my assertion, including coastal or ocean wind for today and tomorrow. If we decide, if we are able to do that, we really don't have shortage of solar, wind, coastal, ocean, all inclusive. For the next 20-25 years, I don't see there should be any problem. Then where is the problem? Sorry about this. The problem is solar and wind electricity is available, not available 24/7. It is available when sun shines and when wind blows. Basically, when God wants it. So basically, it is not controllable. Whenever the sun is shining, whatever I have actually put in, the photovoltaics, I'll get that much power. I can't control it. I can't increase it. I can't decrease it. And if I have to then utilize them immediately. And how do I make it 24/7? For example, if the sun is shining in the daytime and I need to use it in the evening, the only way I can do it is through energy storage. So my talk considerably is going to be on energy storage. Now, again, I'm making the same point. Electricity produced must be used immediately. We have to match generation to demand at every instant. About 10-12 years back, we used to produce less power than what was the demand. And that time, we used to do load shedding or power cuts. And that was an easy way to match it. In certain area, we'll cut power, sometime for half an hour, 1 hour, sometime for 2 hours, 4 hours. In Tamil Nadu, it used to be as bad as 8 hours when required. And that is the way load and demand, generation and demand was met at every instant. If demand was less than the power produced, then we didn't know what to do. We could try to reduce the power generation. For example, if it is an oil or gas-based plant, it is possible the next minute I reduce the generation power. If it is a coal, I can reduce it. But coal is burning, so I can't reduce it instantly. I can reduce it in maybe half an hour, time lag and all that kind of things. And in spite of that, if there is an excess power, well, you have to dump it. There is really nothing that you can do. There used to be a lot of work 15 years back on what is called demand management or smart grids. Basically saying you encourage more power usage when there is just excess and discourage power usage when it is in deficit. You do that by actually decreasing tariff and informing the user, now if you use it, your tariff is going to increase. And so maybe user may postpone the demand. And this has been done. There is a lot of work that has gone on. To some extent, it is possible. But if it's a major thing, you really cannot actually do this. And you will need storage. So essentially, it comes back to this. That electricity produced has to be stored. Now, how do you store electricity? You cannot store electricity in itself. You have to convert it to some other form of energy and put that other form of energy and then reconvert it to electricity when needed. And when you convert it to other form of energy, there are losses. When you convert it back to electricity, there is losses. So you call that a round trip losses. You have to worry about those round trip losses, but you have to worry about the conversion and you also have to worry about the losses. And whatever the storage cost has to be added. Pumped water is a traditionally well-known method. So you pump the water up and store it in a storage and let the water fall. So when you have excess supply, you pump the water. When there is a shortage, you let the water fall and generate tidal power, and that could be used. The storage for pumped water has about 30 to 35% losses. It could be a large power plant because large dams can be used for something like that, but it has a high losses. There has been a lot of work on this mechanical flywheels, which are put into vacuum, large flywheels, and they will rotate. As they rotate, you have to put in energy to rotate, and then it rotates freely. The only problem is that any such mechanical thing will start losing energy after some time, and it is therefore fairly fast decaying energy. But a lot of talk has been converting into hydrogen, storing it, and then using it, conversion back to electricity. It is still too expensive, very expensive. We remember that we are talking about 2 rupee 50 paise or 5 rupees or something like that. Here you are still talking about 50 rupees per kilowatt hour. So over time, of course, this may come down, and we may have to keep on working on this new technology towards this, but currently it is far away. Then there are chemical batteries. Chemical batteries, because you convert electricity into chemical energy and then reconvert to electricity. Of course, we have all kinds of batteries. Lead acid is very, very common. Lithium ion is getting a fairly dominant position over time, and my talk is primarily going to be on lithium ion batteries. There are other batteries, solid state batteries, there are redox batteries, all others, but today the economics doesn't work out for any one of them. As I'll point out, it's a lithium ion which dominates. We will look at that in greater detail. So what is the mechanism? Mechanism is fairly simple. You have an AC grid where power is available. Now there is excess power available. You convert this AC power to a DC by a bidirectional converter. Now it has to be DC because the battery only stores DC energy. And then you store it in a lead acid battery or lithium ion battery or some other form of batteries. And then whenever you need more power on the grid, you draw the power, and therefore it is a bidirectional converter, and use it. It is something, these bidirectional converters are easily available. This is a power electronics work. There could be some work probably going on in IIIT Hyderabad also. You need large power electronics. You may do 1 megawatt or even 10 megawatt converters. And then you need very, very large storage. I'm going to talk about that. There are two kinds of storages. One is what is called short-term storage, where basically what you do is that for a short time, if the demand is higher than the supply, you reduce the frequency, and if the demand goes less than the supply, you increase the frequency. That's called frequency control. And it's a very short time, and you rapidly store some energy and take it out. It's more to keep this grid balanced all the time. I'm not going to talk about it, but this is not large storage. This is not will help us in solar and wind. Solar and wind, sun shines in the morning and I have to use it in the evening. So these are very, very short-term storage. What I'm going to talk about for renewable energy, and essentially the idea is that basically have fairly large shifts of time, maybe tens of hours, 10 hours, 12 hours, 14 hours, and just use it. So that is what I'm going to talk about. And what I'm going to do is look at, as I told you, the economics of it. How much does a storage cost? Now, when you buy storage, you buy a battery. There is a capital cost. When you purchase a battery, there is a capital cost. So capital cost may be very large, and it will last for a certain number of years or a certain number of cycles, what it is called. So I have to actually convert it each time I use it. How much does it cost? So for the capital cost of battery, whenever there is a capital cost involved, you have to use what is called depreciation. You have to find out the lifetime of the battery, and over the lifetime of the battery, you have to depreciate the cost till it becomes zero. And you all the time, if you are going to borrow money and buy this, you'll have to worry about the interest cost. So depreciation and interest rate. Depreciation depends on the life of the battery. So that is the second part. How many times it can be used? How many cycles it can be used? How many charge-discharge cycles? Are there 1,000 cycles or 2,000 cycles? You have to worry about it. And based on the number of cycles, you calculate the depreciation. Interest rate is what the bank tells you. And this is one way of converting the capital cost to, let's say, yearly cost, monthly cost, daily cost, and then cost for each cycle. Then you have to worry about usage cost per cycle. Of course, if you are charging, the cost of the electricity, of course, you have to take into account. Is there any other operational cost? Is there any other cost, operation cost? Normally for a battery, the operation cost is very low. Then is there a leakage? If you charge it, and will the amount of energy keeps on going down? If I want to use it after 4 hours, will I lose even 1% of electricity stored, or 5% of electricity? So I have to worry about it. There are certain batteries which have leakage. Many other batteries just don't have leakage. So, or have very, very small leakage. Every battery has to have some leakage. Then an important question that we have to ask to compute the cost per kilowatt hour is, how many cycles will I use per day? Will I use one cycle per day? Whenever sun shines, I will charge. And whenever sun is not shining, I'll use. That's one cycle. You'll find that one cycle per day increases the cost like anything. Can I use 1.2 cycles a day? I charge in the daytime when sun is shining, and then try to use it when the sun is not shining. Then maybe wind comes up, and that time again I charge, and then when the wind goes down, again I discharge. So if I have more than one source of renewable energy, I can discharge more than one time, 2 times. Sometimes the wind will increase, then decrease, or similarly sun will increase, decrease. So I can do 2.5 times or 3 times also. 1.5 times basically means, on the average, every 2 days I'll do 3. Every 2 days I'll do 3 cycles. So we will do the computation for all of these possibilities and what does it do. And then we'll have to calculate effective cost per kilowatt hour of usage. Now, very often we stop at this and we don't take into account that do these batteries have environmental impact, toxicity, hazards, and recyclability. I think they are important parameters to be considered. If you don't consider, we are really not taking the full cost of the electricity. I am not going to actually consider this for lithium-ion batteries, because lithium-ion batteries today, we have learned to recycle. And when we recycle, the environmental impact and all other things becomes practically negligible. So because that technology, I'm not going to talk about that technology, but that's what I'm going to talk about. So let us assume that sun is shining and I am generating solar power. What I do is that it is in daytime and I'm using a lot of power in the daytime. So let's assume 70% of the power I use instantly. That will cost me ₹2.50 per kilowatt hour, because that's the cost of solar electricity. I use 70% in the instantly, and 30% I use it for the evening. So evening or when sun is not available. So I put it into the storage and let S be the cost, and then I'll take it out whenever needed. So the cost becomes ₹2.50 per kilowatt hour plus S. So this is the cost of the 30%. This is the cost of 70%. Now, you may ask me question, why have I taken 70% or 30%? I've just taken that as an example. In fact, these are close to the number that we actually use. 70% time we are able to use it mostly in the daytime. 30% is what we need for later part. But actually later on, I'm going to make changes there and show you what happens when I take 50% you immediately uses and 50% through storage. Well, if I use 70-30, my average cost works out to be 70% into 250 plus 30% into 250 plus S, which is ₹2.50 plus 0.3 into S. So all that will happen if I want to use 50% through storage, this will become 0.5 S. So that will happen, and we'll see the impact of that. Right now, let's take it as 30%. Now, let me take some battery. I'm taking batteries. When I take batteries, I have to worry about type of battery, effective life cycle of the battery, what is the capital cost. I have to worry about number of cycles that are used per day. I have to worry about end-to-end energy efficiency. Remember, electricity is going to be converted into DC and then into chemical form and then converted back into electricity. What is the total losses? I've taken assumed loss to be 95%, which is fairly good. I can actually do better than that. I can do 96% or slightly higher. Then there is something called interest cost. Interest cost is that if I borrow the money and build this plant, this is what the bank will charge. Now, I have taken a range from 2% to 10%. 2% is the interest cost in United States, Europe, Japan. In India, the interest cost is more like 11, 12%. Your director will be able to tell you some money that they borrowed, what it cost them. But long-term interest, you may be able to get it at 10%. So I'm going to show you the impact of interest. Why is it important? Very often our technology comes from the West. All the computation, etc., comes from the West. They therefore use 2% interest rate. And then even our policymaker blindly try to use it and recommend one technology or other. I will show you that if you take Indian interest rate, the scenario completely changes. Unfortunately, we don't even do this calculation. We scientists have to be fairly aware what the impact of the interest rate is in the cost of any service that we provide. I'm now taking 3 types of cells, battery cells, which are available today. They are in my lab. All these 3 are actually exist in my lab. And I'm not therefore taking tomorrow's cost. I'll later on talk about tomorrow's cost, but I'm taking today's cost. And then there may not be the best cost. With those costs, if I build a kilowatt hour of battery, the cost with cell A is 15,000 rupees, with cell is 22,500, and cell C is 35,000 rupees. Actually, these are not the number for 1 kilowatt hour. This is the cost per kilowatt hour if I build a megawatt hour of battery. For a kilowatt hour, it will be much higher. But if I build a megawatt hour of battery, which is what I will need for my storage, then this is the cost at which I can build. Of course, in a large size and in large number, not one-off, not my R&D cost. This is not my R&D cost. Number of cycles that this has 2,000. What does it mean? This is the NMC material, and 2,000 times it will be charging, discharging, and after that the battery will not be usable anymore. You have to replace the battery. Thus, with the cell B, I can go up to 7,000 cycles. So the cost is higher, but it's an advanced NMC, it's a very good cell. I can go to 7,000. Such kind of cells are now available. Cell C is a different chemistry, LTO. It's cost much higher, but number of cycles also I can go much higher. So now, with these 3 cells and interest rate going from 2% to 10%, assuming end-to-end efficiency of 95%, with 1 cycle of usage, 1.5 cycle of usage, 2 cycle of usage, and 3 cycle of usage, let me do a computation. And here is what I have computed. Now, I would strongly recommend that every technologist understand how to do this simple computation. It's actually, I mean, I teach it in my class. It takes about 2 hours to learn. It's a simple Excel sheet understanding. How do you calculate for the life, the depreciation, for the interest cost? How do you take into account number of cycles, usage per day, and do all of this? And for each of those 3 cells, I have done it for 2% to 10%, and I'm presenting the result. Let me take the first case where number of cycles per day usage is 1. I'm using sun, daytime I'm charging, using it in the evening, the battery. Look at the 3 cell. This was the low cost cell with 2,000 cycles. You see that this is the kind of cell that we use for electric vehicles. It's not very useful. First of the cost is quite high. The cell B and C. Cell C is the LTO and cell B is the advanced NMC. If I was in US or Europe or Japan, you can clearly see that cell C, the LTO cell, is very good. But because the interest rate is around 2%, when I come to India with the interest rate 10% or more, you see that LTO is no good. It is the cell B, which is the advanced NMC cell. And this gives me about 8 rupees per kilowatt hour. Expensive, but I'll come to that in a few minutes. Now, this is where the mistake is often made. For example, Indian government or some of the some of the discoms are now buying these batteries, and they'll end up buying LTO without even understanding that our costs are going to be somewhere here, 12-13%. Okay, but this is 8 rupees. So let me now focus on the cell that we should use, advanced energy cell, something like 5,000 to 7,000 cycles, 25,000 rupees. If I do that, my cost comes to 8 rupees for one cycle. But what if I'm able to do 1.5 cycle? I have solar and wind, so I have this offset. Suddenly my cost goes down to 6 rupees. Very, very interesting. And if I can do even more, let's say I do 2 cycles, my cost comes to more like 5 rupee 30 paise, 5 rupee 40 paise per kilowatt hour at 10% interest. It's a fairly flat curve. Even if it become 11, 12, it is not going to be too much more. If I could do 3 cells, my cost would have come under 5 rupees. But that is unlikely. So what I have to really focus on, maybe 2 cycles per day as much as possible, occasionally 1.5 cycles per day. And this is the cost that's varying. So let me summarize that now. So the cell B, the advanced NMC, works out to be the best. 1 cycle, 8 rupees, 1.5 cycle, 6 rupees, 2 cycles, 5 rupee 30, and 3 cycles I'm ignoring right now. If, of course, I was in US or Japan or in Europe, it will come down to 3 rupees. Just look at this. In the West, it costs only 3 rupees. For us, it more than doubles. This is what happens with interest cost. Initial capital cost matters, but it is the interest cost that kills us. Whenever we do any technology development, R&D, and with the objective of commercialization in India, we must understand Indian economics with Indian capital cost and Indian interest cost. We do not teach that, and I strongly recommend to PJN that please teach this in triple IT. If you want, I can take a small 4 to 8 hours sometime for your R&D people there, for your students there remotely, and teach something like this. This is important that we understand Indian costs and all that. So our cost is 6 rupees for 1.5, 5 rupees 30. What does that mean? So this again, I'm summarizing. Our cost is 8 rupees, 6 rupees, and 5.30. One cycle is I'm kind of ignoring with interest rate of 10%. Now let's go back to the 70% I'll use directly and 30% through storage. My cost is 2 rupee 50 plus 0.3s. So if I do that, my R becomes, for this is 5 rupees, for this is 4 rupee 30, and it is 4 rupee 10 paise. Now this is, of course, when if I use only 30% through the storage. This is the average cost of electricity. This is not bad. I am sure IIIT Hyderabad pays much more than this. We at IIT Madras Research Park pay 10 rupees, and I'll show you, in fact, 11 rupees. So here I can get solar and wind at this cost. So the cost varies from 4 rupees 10 paise to 4.90. Most of the time I'll be able to do 2 cycles. So I'll cost me more like closer to 4.30 on that most of the time, not 4.90. So 4.30 is what I will assume as my average cost. Now, this is when if you do 30%. Now, somebody says, what happens if it is 50%? Of course, if it is a 50%, cost will go up because you look at this. It will become 0.5s, cost will go up. My cost will become 5 rupee 15 to 650. This is slightly on the higher side. Maybe 550. Instead of 430, it will become 550. But you know, the cost of batteries are going down, cells are going down. What I have taken is a current cost. If we start using that, overnight we are not going to convert all our things to renewable. Only small amount will be converted to renewable. So 30% is good enough for today. By the time my storage is built, the cost of storage will come down. And storage will come down. And in fact, at 50%, it will cost will be same, 4 rupees, approximately 4 rupees. This will happen in 3 to 5 years. So we don't have to worry about this 50%. I can say this storage cost will be 4 rupees today and will be lower tomorrow. It's not going to be higher, average cost. So as I told you, in 4 to 5 years, this whole thing will go down further. So we don't have to worry about 50%. When it comes to 50%, we'll worry about it and the cost could have come down. Now, the only problem is with all this, if we sort of leave it and sort of say, well, this is available today. I'm building that storage, 1 megawatt hour storage at my lab. It's available elsewhere in the world also. Nobody else in India makes it, such large size storage. So we'll import, and we unfortunately don't even understand what we want to import. We'll end up importing wrong things, but yet we'll give the multinationals total hold on this sector, just like we have given them hold on many, many sectors. And after some time, Indian technology will find it very, very difficult to get. Even though they are importing at higher cost today, in India we'll be able to build it at lower cost. But so we don't have experience of building 100 megawatt hour or 200 megawatt hour, and therefore we'll be disqualified. It will take us 2-3 years, and by that time multinationals will take big hold, and after that Indian technology will never get there. So what do? Do you just sort of say, well, this is new, this is hot, this is just starting to come up? Is this another place where we lose? Not necessarily. If you are intelligent, we as R&D often have to find how do you go about getting to beat the international thing. Our R&D should help us. So the question is, can we begin somewhere else? And I am showing you a picture here of IIT Madras Research Park. This is the complex that I have built. It's a 1.2 million square feet. It's a R&D complex. You know, ITI Hyderabad is a very similar complex. Maybe slightly less size. It may not be 1.2 million, but it doesn't really matter. It may be 700,000. But there are some hostels and other things. So you may also be consuming as much electricity. What if we start here? Now, ours being a R&D complex and not an education complex, there are 40,000 such complexes in India. Today, cost that we pay is a commercial building cost. And commercial cost is high, 10 rupees per unit. We pay 10 rupees per unit. Actually, we pay 8 rupees 50 paise per unit, including taxes. Plus, we pay demand charges of 1 rupee 50 paise. Or we used to pay more like 2 rupees demand charges. So it comes to around 10 rupees per unit. That is what we pay today. And we consume a lot of electricity. My bill is around 75 lakhs rupees per month. So fairly large. And in my complex alone, and there are 40,000 such complexes. Then when there is a power cut, I have to use a diesel generator. And diesel generator costs, in fact, not 22 rupees in recent time, it has gone up to 25 rupees per unit. Now, this adds another 10% to the cost. So my average cost is 11 rupees per unit. Can I do something better than that? Of course, if I had enough rooftop, I could generate solar electricity at 3 rupees per unit. But I have only enough space. I already have solar panels. I can generate only 10 to 15% of that electricity. Fine. What do I do for the rest? There are independent power producers who generate renewable energy and sell. Have solar and wind energy farms and some coal-based. I can actually bring them here, and they will even give me 24/7 power at around 650, slightly less than what I get from DISCOM. But I have to have a long-term contract. I have to have a minimum power per day and all those kind of things. I will not even use them because this doesn't give me 100%. It is a mixture of solar, wind, and coal. What I will do is something else, therefore. Can I go for what is called captive solar and wind generation? Not at my campus, but somewhere else where there is land available, 200 kilometers away, 150 kilometers away. And can I wheel it to my building? Now, fortunately, I don't have to take the land and do it. There are companies which will make number of such complexes our customers, their customer, and say, okay, on your behalf, I'm going to generate 4 megawatt. On somebody else's behalf, I'll generate 6 megawatt. For somebody else, I'll generate 8 megawatt. Totally, my generation will be 300-400 megawatt. Then only, and it will be solar and wind. Then only it becomes cost competitive. So such kind of companies are available. They charge slightly high, 2 rupees 75 paise per unit. They take small amount of investment. They don't take major investment, but small amount of investment they take from us. So I can get the electricity. I can get solar and wind as and when it is available at 2 rupees 75 paise is the cost of generation. Then I have to have a transmission and wheeling cost. I have to pay ₹1.50 for that also. So together I can get it around 4 rupee 25 paise, 4 rupee 30 paise. So this is possible. So once I get, my only problem will be when solar energy is available, and if I need less than that, what do? I have to take that because I bought that. I will then need storage. What if I create my own storage? 5 megawatt hour to 20 megawatt hour. Initially, I'm starting with 1 megawatt hour. In my internal grid, whenever there is excess, I put it into the storage battery, and whenever it is deficit, I'll take it out of the electricity. Now, this will be the lithium-ion batteries that I'm building. But I've also got a chilled water storage. Half our energy usage in office buildings like ours is for air conditioning. What I do here is that I chill the water whenever there is excess electricity. I chill it to 6 degrees centigrade and keep it. And then circulate that water for cooling when I need cooling. Instead of chilling the water at the time of usage, I can chill and store the water. Of course, I have to build a large storage, and I've built such storage in basement. Of course, every 2 hours, I lose about 1 degree or half a degree temperature. I have to worry about it. So I have to use it in some hours. Otherwise, I'll lose some energy. But actually, it is a very, very viable thing. So both this and battery can be used. And I'm starting to use that. So now let's look at the economics. Storage cost, as I pointed out, for a 5 megawatt hour will cost me 7 rupees per unit over its lifetime. If I only store 30% of my electricity and 70% use directly, my storage cost as 2 rupees 10 paise. So what is the total cost? Generation cost of solar and wind remotely in that manner will be 2 rupees 75 paise. Transmission and wheeling will be 1 rupee 50 paise. Plus there is a storage cost of 2 rupee 10 paise. Plus, because I'm going to use DISCOM's cables, I not only have to pay transmission and wheeling cost, I have to also pay demand charges. How much electricity I need at maximum peak, and I have to pay 1 rupee per unit for that. Today I pay higher because I'm not able to optimize. Once I have storage, I can optimize, and I'll only pay average cost. So my cost will be 2 rupees 75 plus 150 plus 210 plus 1 rupee. Remember that to the DISCOM and transmission, I'm paying 2 rupee 50, which is high, but this is what the rule law is, and I'll have to do. Of course, I'll have to do energy management to be able to get there. So I'm actually effectively, I have to pay 7 rupee 35 paise. But today I'm paying 11 rupees per unit. So what is the problem? I'll save almost 30 lakhs rupees per month. In fact, IIIT Hyderabad can also do it, and it will save costs. I don't know what is it. We are paying 11 rupees. They may, if they get concessional electricity, it's a different thing. But all the commercial organization gets it at similar costs. This includes the diesel generator, and I'll get 24/7. So it makes economic sense today, not future tomorrow. Of course, this is assuming 70% is used directly and 30% is storage. Now, over time, my costs will further come down. First, my captive energy today is 275. I can negotiate and work it out to 225 over time. My transmission, wheeling, and demand charges clubbed together. Today I'm paying 350. I can bring it down to 2 rupees. And my battery cost, even with 50% energy being stored, will come down to 2 rupees. So in my future, my cost will come closer to 6 rupees per unit, 625. And this is not too far off. This is 5 years, within 5 years, 4-5 years. So, and I eliminate 24/7 diesel generator. This with this 6 rupees, and today I pay 11 rupees, and that will keep on rising. This is not going to rise. This is already capped. So, in fact, I'll recover my cost in very, very few years. And since there are 40,000 such complexes, can I build it, commercialize it, put it in my place, and then start putting it all over the country? Possible to build and deploy pilots within a year, and we plan to do that. It makes business sense. Then there are 40,000 such complexes. Now, if I put a 15 megawatt hour per complex of storage, I may put larger at 22 rupees 5,000 per kilowatt hour, and at 40,000, my total market size is 14 lakh crore or $200 billion. Can you imagine 14 lakh crores? Remember, the total GDP of India is 200 lakh crores, and we can add so much to this. Now, if I get only 10% market, which is what I'm likely to get, I can get 1.54 lakh crore or $20 billion. Very big. This is storage and the converters. This is the potential of technologies like this. And this is where India needs to win. Our R&D need to go into commercialization. Remember, it is not just a money issue. What is most important, I get 24/7 renewable energy. I get rid of diesel generator which pollutes. I am going to move India towards renewable energy. And once I build enough of this, building 200, 250 megawatt hour is trivial. Actually, 15 to 20 megawatt hour, 250 megawatt hour will consist of 10 of these kind of plants. Maybe it will go to 30, 40 megawatt hour. Nobody build bigger than that. So then I should be able to even compete and get into the grid. I would have enough experience and push out and compete with any imported storage. And the grid storage will further add immense market to us. This is the potential that we are trying to pursue. And what I'm pointing out, I'm giving this as an example, what R&D needs to always do. Figure out the market, figure out how to enter that, figure out at costs, of course, have to figure out the technology that has to be actually carried out and take it all the way to commercialization. To sum up, fortunately, India has abandoned renewable as energy. We have enough solar and wind all over the country. Andhra Pradesh, for example, has huge, and Telangana has huge capability of both, with solar in particular, not as much on wind. Many other places has solar and wind, and some other places have wind. You can have a good mixture of both solar and wind. And if people say, what will happen during rain? Well, first of all, it doesn't rain all over the country at the same time. For example, the whole southern India, Tamil Nadu, and all these things actually do not get rain during monsoon. We get rains during December, January. So there is plenty of diversity in India to take care of it. And if you go to Rajasthan desert, there is practically no rain, 4 days of rain in a year. And there is 12-hour sunlight. So it is possible for us to put plants all over the country, solar and wind, including wind farms at the coast, and put enough storage in India, and it can make 24/7. It will make economic sense. Today viable for office complexes, tomorrow it will be very, very viable for all of this. Of course, I'd want to end by sort of saying, I have taken only one storage, lithium-ion battery storage. I'm not saying that this itself, lithium-ion battery may itself evolve. I may get solid-state battery. But there are other storage, for example, hydrogen storage, liquid air storage. They are very useful. For example, if you want to store energy for 1 month or 2 months, if there is a huge period of not enough solar and wind, then you need to store some energy. Liquid air could be a very, very interesting technology. Pumped hydro storage becomes very, very interesting technology. Hydrogen storage becomes very impressive. Compressed gas becomes very, very important. And all of this, as I pointed out, needs research and development and innovation and commercialization. If you don't do that, you don't win. And we need to win for India. We have the capability. By and large, our capability matches that. In some sectors, we are behind. We'll have to figure out what to do. But overall, we can actually get there. And I think with that, I will stop my talk and I'm open to questions and answers. Because I finished about 15 minutes earlier, I'm stopping sharing so that you can ask me as many questions as you want. I'm willing to share the talk. I'll send a PDF of it. You need to write to me, unless you write email to me, and I'll give you in the chat box my email address, ashok@tenet.res.in. If you are willing to write to me, I will send you the talk. Thank you very much.
Sure. Thank you, Professor Chunchantala, for an excellent.
Thank you so much, sir.
Are there questions and answer? Any one of you have? I see only very few people. Most of you, they may be watching on the YouTube. So I don't know what you.
Yeah, I request people who are watching on the YouTube to post their questions as a chat or a text message there. We will try to get it here. And we have a few people in the Zoom room here, so they can possibly switch on their camera and ask questions. So I see Professor Vishal Garg has already raised the hand. Vishal?
Thank you, Professor Jhunjhunwala, for such a informative talk and coverage a wide spectrum of things. Thank you. I really like the thermal storage piece. That is for the air conditioning that you mentioned, for chilled water. That's very important for us to consider. I have a few questions. One of them is, what are your thoughts on semi-transparent photovoltaics when we are talking about tall buildings and buildings not having sufficient roof area? So do you see a future here, the cost coming down and this being used for windows?
So there is a lot of work going on, a whole lot of photovoltaic generation, including semi-transparent photovoltaics. There are different stages. Will they come down to the cost level of say multicrystalline or single crystalline silicon that we are using, give higher efficiency and similar cost? In what time frame? I cannot predict. There are all kinds of papers which predict that it may happen. Sorry, somebody else is talking? No, I think there is just an echo. So I can't exactly say, but yes, welcome any way of generating solar energy. If a newer cell comes, today unfortunately we import almost everything from China. Tomorrow hopefully we'll have some cells which we can use. Most welcome. Again, R&D to an innovation to commercialization. Without commercialization, we can in our lab do all the work. It has practically no impact.
Right. So my second question is, we are going to see a lot of variability in the grid because of the renewables and also because of the electric vehicles. We talk about smart cities, we talk about smart grid, but where are we in terms of demand response and smart buildings? How,
I think,
how will this whole thing, all these pieces fit together for us to reach 100% renewable world?
Yeah, I think all these smart grids, etc., or demand management, load management, and all those kind of things is going to go only so far. We should continue doing work, but the focus should be on storage. If we have 100 gigawatt hour on the grid or even more, which we can build and it pays for itself, then we really will not have any problem. And it is the same lithium-ion battery which goes into the vehicles, it'll as well as this. So there is a huge advantage. You know what I did not even talk about? What about the second life of the battery? The battery doesn't go to zero. By the time they go to 70% or maybe 65%, I will take it out. There is still, I can use it somewhere else. I can recover the material and reuse it. All that is going to help improve my economics. I have not taken all those things into account. I've just sort of said today's economics. This is more or less the worst case that I have presented. Or I won't say worst case, today's case where I don't do everything else. But all this becomes possibility. And, you know, I did this for one area. I think there are at least 25 areas in which India should do this. This whole slogan, Atmanirbhar, will become just a mere slogan. I'm very worried about this kind of slogan and not really become Atmanirbhar. And just manufacturing doesn't give I think we really need to do value add, which means R&D to and innovation to commercialization. It is that what is required. R&D and I and C is what is required. And I want to emphasize that. Thank you, Vishal.
Thank you. Thank you.
Any other question? Yeah.
Sure.
Yeah, so Professor Junjunwala, very nice talk, very informative, and then a new perspective to to normally what we think in terms of energy storage and everything. So people also talk about energy storage like physically, for example, hydroelectric storage, or people even talk about, for example, freezing water during the day and then using in the night, or use it for cooling the next day, and then pushing rocks on the hills, different kinds of things in terms of physical storage of electricity. So what is your thoughts on that, or what are the efficiency like? How do we compare the efficiencies?
Yeah, you have to just do two things. First, compute the efficiency, that end loss. Here I have taken 95%. You have to take into account the loss, and you have to take into account the total cost. The way I did, capital cost, interest cost, number of times it can be used. All those things is what you have to do. For example, chilled water, I'm using it. I don't know whether ice is, because the latent the energy that I require, that I get to convert it to ice is fairly large, and that I don't know how effective it will be. But up to chilling, and if I'm going to use chilled water the same day, it really works very well. But somebody can go one step further and so say, convert it into ice, and then let ice melt. I think these are all very, very interesting work, and if we can show that techno-economically it works, fantastic. Except if you have to make it ice, you have to go below zero. I'm able to go up to 6 degrees centigrade. My normal chillers, HVAC systems do that. So I have not put any new equipment. I have only put a large storage, large space. It is not a box. It's actually a big room, completely sealed room. Storage tank I have created.
Yeah.
Thank you.
I'll take a question from the online or YouTube. So Government of India gets loan at 6.22% of interest. So does having a PSU doing the same would help?
The best rate at which today industry, whether it is a PSU or private sector, is about 8.5. This is the current level. It used to be 12, 13. It has come down slightly, keeps on fluctuating. It to some extent depends on oil price. Oil price has become 7 years back was $110 per unit. So then the interest rate had gone to much higher. Now it is low, $50, $60. So it has gone low. So we do not know. But long-term average, for example, for solar, you need to have investment for 25 years. And today that fund is available between 9 to 10%. So I've taken 9 to 10%. Will it further fall down? I don't know. This is not something that we can kind of say. And whether you take international loan or whatever finally it comes down to 8-9%. I mean, you have to do, when you take dollar loan, you can get it at a lower price, but then you have to put hedging. The reason is, what if the dollar price goes up? So it comes to roughly the same. Let the bankers do the job. I don't want to do the job. Today, average cost is about 8 to 9%. So yes, instead of 10, it can probably become 9. But now till a couple of years back, it was 10. Few years back, it was 12. So you don't want to take and then keep on fluctuating. Housing loan today is what? At what rate? Anyone takes housing loan? At what rate? And this is, by the way, concessional housing. Housing loan is under priority sector. Maybe here also we can get concession. But what is a housing loan? Anybody is building house has taken housing loan? None of you can afford to take housing loans?
It's about
I think it has dropped to
7.5%.
10. Dropped to 10 now. Of late, it has dropped. It is about 10% now if you take a new
So I
loan.
think it's about 10%, 9% is a reasonable rate.
So is there a model to calculate the environmental costs of battery, the chemicals?
Yes, you can. The reason I add into, if I were the lead acid battery, I would have included that. We can put the numbers. For lithium ion battery, we are seeing that we can recycle and get 90%. And there is a value created. So I'm really not putting it that right now.
Yes. Aftab, you have a question.
Yes, thank you so much for that wonderful talk. Sir, I just wanted to ask you, because we are using lithium ion these days for everything from very small storages in mobile phones to megawatt capacities, do you think that will eventually put a lot of pressure on the amount of lithium that is being extracted from the earth and lithium being...
If you don't recycle, yes. But
yeah,
we are able to recover today 93% of the old battery. So we will keep on reusing the same thing again and again. Now, over time, this will change. There are a lot of solid state batteries coming up. The amount of lithium may decrease. I don't know. So this is not something that you need to do forever. I'm fairly certain 10 years down the line, we'll be using some other materials. No, but the point is, what we are doing is making packs. We are not making cells. The cells pretty much will remain similar. Now, in pack, therefore, I have to change a lot of parameters, a lot of software I have to change, a few mechanical and thermal properties parameters I have to change, but nothing major. This industry's pack making is going to become a very important industry over time.
So there is one more question. Let me pick from online. This is about can this be implemented for gated communities in metropolitan cities? Is there any change?
If you are getting a concessional rate of electricity, it may not work out to be viable. But if you are, like as I told you initially, the industrial houses, initially should be done for industrial houses and for commercial complexes which are paying higher. So if you are paying already less than 7 rupees, you may do it, but you don't get that great advantage. And I think many of these gated community may be paying average of 7 rupees. Of course, you are still giving 2 rupee 50 paise for transmission. And in my current calculation, you are giving almost 2 rupee 50 paise. That is high. So eventually that will come down. Eventually this will be done by the generating station, solar and wind itself. Then that cost will go away. Then it will become viable.
Okay. So there are more questions online. I hope we can take a couple of more questions.
Sure. I still have some time.
Yeah. Is a decentralized network of local solar storage between each house is a viable option?
Sorry, can you repeat the question, please?
Is a decentralized network of local solar storage between each house a viable option to solve the problem of unequal distribution of energy?
Well, when I'm talking about trying to put in 40,000 commercial complexes, I'm talking about decentralized. Can you put it in every home and do that? Yes, to some extent. But finally, I think you'll require large storage. Home economics is very different. I have built 3 kilowatt to 9 kilowatt solar systems for homes. Let us see how successful are with a 5 kilowatt hour to 15 kilowatt hour storage. Let's see how successful we are, because you pay for homes, you pay 5 rupees, 6 rupees per kilowatt hour. So we are suddenly competing with those kind of things. The storage cost needs to. Fortunately, if I do rooftop, then my 2 rupee 50 paise gets saved. So I may be able to just about do things. But the size becomes all very small. And when the size becomes very small, you don't get the advantage. I mean, today I can do at 22,500. And my generation cost, I can do that. All the electronics cost gets distributed. In a small thing, it doesn't get distributed. For multi-story complex, can I put a 30, 40 kilowatt? Probably I can do that. And that's where I can save on a lot of costs. That's the next thing that we should really look at.
One more question.
Yeah.
Is government planning to build renewable energy setup more rapidly since the petroleum prices are increasing at a rapid
rate? Yes, it is, except it gets all its advisors. It doesn't get advisors from academia. Somehow, this is a peculiar thing. It has become worse. The previous government used to do at least more consultation. Today, how many times PJN is consulted? Huh? No, I think that's where the problem is. Somehow they believe that only the international community can be consulted. So they don't really focus on Indian R&D. As I pointed out, therefore, have they talked about R&D? Have they talked? Do they consult the academia? Mostly no. Mostly no. Very small extent. It has gone down. It used to be little more. Even that was not adequate. But today it is even less. Of course, our weakness, we only talk about R&D and not all the way to R&D to commercialization. Yeah. So I had to accept our weakness.
Yeah. So Vishal has a question. Before that, let me just take one more question, possibly from the online, which is possibly related to technology. So there are a number of questions centered around what type of technology. I'll just quickly summarize them. So one, there is a question on what is your opinion on wave energy generation. There is another one related to
sodium. I think wave energy generation can be done. It has to be commercially viable. So any of such thing can be done.
Sodium sulfur battery. Solid state battery.
Unlikely to compete with the lithium ion. That's often I may be proven wrong. I'll be very happy when I'm proven wrong.
Okay. Thank you. Yeah. So let me, Professor Vishal.
So Professor Jhunjhunwala, so right now, the commercial people are paying more and the residential people are paying less. And all these things are making financial sense for the commercial people, right? It's commercial buildings. Now, if people start at, for the utility, these are the ones from where they are getting the profit. And then they are subsidizing the residences and the agriculture.
I understand.
Everybody in commercial goes for this. And then assuming the 100% renewable scenario, so the grid becomes only wheeling, right? Only transmission.
Yeah.
What will happen to the sunken cost and how will the cost change over time? Will it continue?
So I have some understanding of that. Of course, a lot of golmaal goes on in DISCOM. That I don't want to discuss that too much. But if you look at it, I have in my computation, I have taken 2 rupee 50 paise that goes for transmission and distribution. So 2 rupee 50 paise, they are still getting in this, though they are neither generating nor they are putting storage. So 2 rupee 50 paise, they are still getting in this. So this is not a model which is a anti, they are getting 2 rupee 50 paise without doing anything, but just for utilizing their asset. And actually, if you ask me, taking into account everything, what should be the actual cost of transmission and distribution? Should be more like 1 rupee. So this, I think, is a long-term sustainability is there. Of course, a lot of reforms are needed. That's a different issue. The other thing is, tomorrow, there will be solar and wind generator. They will put storage there, not at the destination end. We are putting a destination end because that's where we can start with. If it is put there, then this T&D all gets solved and they will get 24/7 renewable energy, which then they will take the distribution cost and add it. The cost, their cost will be around 4 rupees for maybe 4 rupee 50 paise, and now they have to add distribution and other things and to charge that, which is less than what they are getting today, and that will be 24/7 electricity. So the direction is very clear. You have to just keep on moving. Policy reforms will always be an issue. Unfortunately, once again, it is somebody else who will not think of India while deciding the policy. If you think of India, the policies will emerge. In fact, support to R&D will emerge if you think of India. But then R&D to commercialization should be the demand, not just R&D. R&D which sits in your labs, what does it do? It doesn't. It's a cost center. It is not a something that is changing India. It is not changing India. We in the academia have to say, and that's what the research park that we built is trying to do: R&D to R&D and innovation all the way to commercialization.
Thank you.
Thank you. Thank you for an exciting talk and answering questions. A lot of questions and rusty excitement. I'm sure we all will benefit.
Anybody can write to me. Again, I'm telling you, I've given on the chat. Please write it on the this thing also on the my email address also on the to the YouTube viewers. Give them ashok@tenet.res.in. I will be very happy to communicate with people, send them my talk, etc., etc. Thank you very much, and I'm leaving now. Bye bye. I have another meeting now in a few minutes.
Thank you, sir.
Thank you. Thank you. So we will now move on to the next part of the Inaugural program. So we have 3 short talks now about 3 different activities that are happening in the R&D in Hyderabad. To start with, let me invite Professor Inaugural Chakravarti to talk about the activities in quantum computing.
Thank you, Professor Jahar. So, am I audible?
Yes.
Thank you very much. First of all, I begin by thanking all of my colleagues who had played a very important role in organizing this particular R&D showcase in spite of the so many constraints and the pandemic situation that is happening. Last time, if we remember that in 2020 we have to postpone, we have to call off this program. So thanks once again, and it's a great opportunity for me to hear Professor Jhunjhunwala's talk. And today, as Professor was mentioning, I will be talking about this quantum computing and what is the prospect of quantum computing and quantum information, and what, as in IIIT, we are trying to do, and we are planning for the future. So, is my screen visible?
Yes. Do you can go to the presentation mode?
Okay. Yeah.
So your video is off. If you can, your video is off.
Video is off.
Yeah.
I can. Okay.
You can.
Shall I on video? I can or keep it off.
If you can keep on, it is good.
Yes. Okay. I'm trying to keep it on. Now it's on.
Yeah. Now it's on. Yeah. Thank you. Yeah. Please go ahead.
So, yeah. So as my part of the talk is the quantum science and technology that is happening in IIIT Hyderabad. So first I will try to give a gist of what are the things that it can do in the near future. So it's quantum computation and information has become the frontiers of science and technology over the last 2 decades. And we have able to achieve theoretically a lot of things that we are not expected to see in the classical computing and in classical information processing. So there are certain pointers in these directions, and we sincerely believe as a researcher, as an academic in this field, that the quantum computers can fundamentally change the things that we can do. Right now we are doing. So what are the things? So when we talk about, and when we and there is a lot of initiatives that are taken from the different levels, from the government level and from the industry level, and the people are getting interested in the domain. The reason is that there are certain things that we can achieve, and there are certain advantages that we can get out of while we do quantum computing and quantum information processing at that microscopic level. So, but there are also some challenges. I here first of all try to give an idea of out of several such pointers. I picked up 5 pointers where we can see that a clear-cut advantage that this kind of method of computation is giving us. So the first thing is that faster and smarter computation, right? So there are several such algorithms which had been designed in case of quantum algorithm, in the domain of quantum algorithms, where we can outperform classical search algorithms and classical algorithms in various way, like. And there are we can solve different optimization problems in much faster rate than what is required, in much shorter period of time than what is required for a most powerful classical computer. Not only that, what are these applicational advantages? So one very important applicational advantage is the drug discovery. There are certain domains where, because of the computational inability, we are not able to encode or decode the molecular sequencing and everything. So in that domain, quantum computer gives you an advantage that it can be done in much faster time, in a much smarter way. So one particular advantage is definitely drug discovering. So for example, in the detection of the cancerous cell, there is a huge time lag that happens in the normal method of computation, and where the medical researchers are also thinking of taking help of quantum computers so to shorten that time domain. So, and similarly, there are other areas like weather forecasting, automation, solving of the optimization problems in large data sets. Even one of the very challenging thing in the weather forecasting is that the time it takes to predict the weather, the catastrophe or the calamity or the disadvantages, all these things happen. So there is a very much constrained approach that is happening right at this moment, and we are losing a lot of money because of this kind of disadvantages that we are facing right at this moment. So one of the prospective direction was for quantum computers to help in those kind of optimization algorithms. And this is one side, and another side we have crypto systems, which are right now the crypto systems are most basically depends upon the mathematical hardness of the problems. When we especially when we have the decoding mapping, so we depend on how hard we set it up in this way that to find out how hard the problem is. But quantum crypto system is something which is completely radically different, and is not a mathematical artifact of the problem. It's the security comes from the nature itself, right? So here is a significant departure that is happening from the classical crypto system, and the secure communication, and it helps a lot, and in the secure communication. And there have been a lot of progress that is happening within India and outside India also, and people are trying to generate keys with the help of the quantum resources like entanglement. So and this kind of security is coming from the nature itself, rather than it is coming from my mathematical way of defining the problem. So we can do also, there is another direction other than the cryptography. There is the different kind of exotic information processing tasks that can happen, which is not possible right at this moment with the classical resources. One of such thing is quantum teleportation, quantum super dense coding, and these are where we can transfer qubit in arbitrary long distance. So all these kind of tasks, state merging, so all these kind of tasks are happening, and these are either happening which are not there in the classical domain, but also we are doing in a much smarter way. So So this will eventually lead us to a system that a classical quantum hybrid communication system. So when we talk about quantum communication is not something that which is completely doesn't take the help of the classical communication or classical ways of transmitting the information. There will be classical channels. There will be classical channels along with the quantum channels. So the system that is coming up in very near future, which is a kind of a system that where we will have both classical and quantum components associated with it. So there will be classical channels, there will be and all these we will have to send classical bits through it, but it will make, what is the advantage that it is providing? It will make the existing system of communication more secure in a sense. So and another very important direction, though this is not the exhaustive set of directions, but this is the some important directions. Another important direction is the quantum machine learning algorithms. So right now this existing machine learning algorithms can be much more improved, and there is a lot of research that is going on where we can use the quantum effects like superposition and entanglement in the machine learning algorithms. And it's kind of a complementing each other, in the sense there are certain quantum problems which we will not be able to solve theoretically. So we apply that standard classical machine learning algorithms, standard classical machine learning, reinforced learning or supervised learning, all these kind of learnings to address the quantum problem. And in the similar type, the quantum mechanics itself also helps to improve the existing machine learning algorithms. Like so now, so these are some pointers in the quantum directions that is creating a lot of news, but also. As a IIIT, for here in IIIT, what are the things that we are presently doing, and what is our future plan in the near future, and what things that we can do in the near future. So so right now we had been working on a couple of aspects. One aspect is quantum communication aspects, where we are working on quantum networks, broadcasting of quantum, so how to build up the understanding the network topology based on the quantum information processing abilities, right? For example, if you have entangled state, which is a kind of a resource which there is no classical counterpart, so having an entangled state gives us a lot of advantage in communications and data transmission, sending data qubits. So, because of the entanglement, the network structures are completely are not very similar with the classical thing. So the networks will have correlations, and we need to learn a lot about what kind of network topology will be important, like random networks or complex networks. So this is something that we have been doing here in IIIT, and also important, we have started doing quantum networks, and also here we are important thing is that broadcasting of quantum resources in a network. There are some elements which we call as resource. So for that reason, resource characterization, what can be a good quantum resource, because it is not very straightforward and one-to-one mapping that this will be resource in this context for all the time. But there is a lot of diversity and complexity associated in identifying the resources and entangled states. So one of the resources is entanglement. There are other resources based on the task that I am trying to do. So all this resource characterization is a very huge area of study, and this characterizing the resource, which can be potential resource for communication and network, is one of the things that we have been doing. And not only that resource characterization, but also we are trying to broadcast the resource across the different parts of a network. Okay, so all these three things we are doing. So and the second part is that the other two, three areas that we are trying to do is secret sharing. That is on quantum cryptography, how to share the secret with the help of the quantum resource. And there are other foundational problems like open quantum system and quantum foundations that we are doing at IIIT. And these are something that, as I have mentioned, that we actually try to do at the we are planning to do in near future. So like quantum machine learning and the how to understand how the quantum effects are playing a role in the machine learning algorithm, quantum algorithms to solve the classical problems, quantum algorithms to solve the classical like optimization problems. We are planning to continue our work on quantum networks, quantum random walks, and various areas like quantum devices, sensors, and quantum thermodynamics and relativistic quantum information processing. This will be important as when we talk about the quantum cryptography with a satellite-based cryptography. In that satellite-based relativistic corrections are something is going to be very crucial. So this is and we are also planning to we are planning to make some PhD program and MS program and bring in courses related to quantum information theory. So the vision right at this moment, establishment of the ecosystem at IIIT Hyderabad, where quality researchers and across the breadth of this field can do cutting edge research in the areas like quantum computing, simulation, quantum sensing, quantum cryptography, and communication. And also the most important resource as an academician providing research and curricular training to the students of IIIT Hyderabad, so that we can equip themselves with the cutting edge tools required to succeed in both academia and industry. So IIIT has different advantages of doing research in IIIT. One of them is the unique structure of the research center, so that we can collaborate with the colleagues of different domain, the flexibility and the collaborative research, and we have a very good research training of the students from the graduate level. All these things together, we are very hopeful, and we are hopeful about that we will be able to do more important things in this direction. So thank you.
Thank you, Indranil. Let me now invite Professor Devapriya Kumar to talk about the IHUB data, the new hub that is getting set up.
Okay, thank you, Professor Jawahar, and everyone, and hello, everyone. I think someone has to mute the mic. Yeah. Okay, so I'll take 3 or 4 minutes and then try to present or talk a little bit about the technology innovation hub that we are establishing at IIIT Hyderabad. So what is IHUB Data? Basically, there's this national mission on interdisciplinary cyber-physical systems, and that is being implemented by the Department of Science and Technology. And the IIIT is establishing one of these technology innovation hubs among many other IITs and universities around the country. And then the one which we are doing, which is called the IHUB Data, is focused on data-driven technologies. It's centered around data, and then how these data can be applied to large-scale problems in certain domains. Right. So one of the most important aspects of the IHUB Data is to be a custodian of data in some sense, where we proactively collect data and then annotate it and then collate it and then clean it such that it is usable for other research. It can easily be consumed by researchers and citizens of the country. And the second one is, once we have the data from collected by us and our collaborators and the ones which are already available, we use data-driven methods to solve large-scale societal problems, and then translate our research to be used in the society. So this IHUB Data not only involves in this kind of application-related work, we also engage with different entities like the universities, colleges, and then young researchers, and then take help from experts and so on, using various programs such as visiting program or fellowships where students can come and work with researchers at IIIT, and then we also will engage in different forms. So this kind of summarizes the whole of the activities under IHUB Data, where we use domain expertise in terms of both data-driven technologies and in terms of the domain experts, like for example in healthcare or mobility kind of areas. And then we develop algorithms and develop technology, and this will be translated into solutions that can be applied in industry or in societal needs. So in terms of the domains that we are, we have started working on, two major domains are the healthcare and mobility. And in addition to that, we also will be working on areas in smart buildings and systems for data for systems, and also choose some problems that are specific to that the country needs. Okay, so this is how the work happens in the intersection of data and different domains. As I said before, we will be the first three aspects relates to activities around data, where we collect data and then annotate, and then we follow, we come up with standards in terms of how to make this process transparent, ethical, and to be protective of privacy and things like that, and then enable and popularize this data for applications and take it for innovations. Okay, so one of the major or the main aim of this whole initiative is to support activities in this whole pipeline, where the technology that we develop as part of these efforts has to reach the land. So the translation is the most important part, where because of which we have several activities planned in terms of the technology development, and then applying these proof of concepts, and then productize them, and then creating field trials or demonstrations and things like that, and finally use startups or industry to take it to the market. Again, as I said, data foundation is something which is fundamental, in the sense that the activities around data is what is going to fuel most of these efforts that we are planning. So in addition to that, we will also be, we also have other activities planned, some of which we have started already, where we will engage with several partners and stakeholders in terms of going forward. So with that, I stop here, and if there are any questions, you can email us and so on. Yeah, thank you.
Thank you, Deva. So let me now invite Professor Sachin Chaudhary to present on the activities related to Smart City and Living Labs.
Just note, I'm sharing my screen. Okay, I hope that you are able to see the screen.
Yes, yes, yes.
Yeah, hi. So hello, everybody. Good afternoon, and it gives me great pleasure to introduce you a new research center, Smart City Research Center. And it's not moving forward for some reason. Okay. So anyway, so there has been a huge push for smart city under Indian government smart city mission, and to improve the quality of life of people by harnessing technology. And under that, there have been 100 smart cities have been declared, which will be funded 100 crores per year for 5 years. And ICT has a big role to play in making a city smarter, and by using solutions which use technology, information, and data to improve infrastructure and services. So leveraging the core and the domain strengths, IIIT Hyderabad has established this new center last year of smart city research. And I feel this is the right time to do so, because so as the research and innovation from this center can have impact to the future 100 basically smart cities in future on 3 fronts: social, economic, and environmental. So since this is a multidisciplinary and very broad topic, several faculty from different centers are participating in this basically research involved in this center. So here is the team. So you can see Ramesh here from software engineering. We have Vishal from building sciences. I'm also there from signal processing and communication background. Deepak is from computer systems group. Then we have Aftab, who is from embedded systems. Prakash is heading the technology transfer office, and Anuradha is the lead architect of this Living Lab project. And of course, there are several interns, students, engineers who are actually doing the actual implementation, deployment, and analysis. Another, basically, here is another photo of the team in a typical Ramesh trademark selfie. And so although the center has started last year, but the seeds were already sown in January 2019 when we started the Center of Excellence on IoT for Smart Cities. And this Center of Excellence has been supported by India-EU collaboration on ICT standardization, TSDSI, and HC. Again, since this is a multidisciplinary field, you see many faculty from different centers engaged in the Center of Excellence. So the Center of Excellence support two kind of activities. One is the knowledge initiatives, where we conducted several tutorial hackathons and workshops, and also research collaboration with EU institutes. So as a part of the research collaboration, two IIIT delegation visited EU, one in January 2019 to Estonia, and second delegation visited to France in July 2019. So me, Vishal, Aftab, and Ramesh were part of that second delegation, which visited France. And based on what we saw, so we saw there the smart building as well as smart city deployments. And based on what we saw there, we got excited, and we decided to replicate those kind of things and convert our campus into a smart campus when we return. And around the same time, there was Mighty was looking for this kind of similar kind of proposals. So we were lucky in that sense, and then we pitched for the Living Lab project, and we got this idea. We got the proposal, and as a result, we have now India's first Living Lab for Smart City Research at IIIT Hyderabad, where we are doing research on different IoT applications or smart city applications like crowd monitoring, power supply, water distribution, smart room, solar, weather. These are just indicative, and we will be doing many more in the future. Good thing about IIIT is that IIIT campus is ideal place for this kind of research, since it's just a right size of 66 acres, not too small, not too big. And we have around 4,000 floating population, including 100 faculty, 2,000 students, 2 incubators, 20 plus research centers. So overall, it is a nice place for academic and industry collaboration. So these are our partners. So Mighty and Smart City have funded this the Living Lab project. Government of Telangana is actively involved, and we also have our network partners EBTC and Amsterdam Arena. And through the COE, we also have collaboration with LAS CNRS, Bordeaux Metropole, and also we are working with IUDX, Indian Urban Data Exchange. I also want to mention here that we are actively looking for corporate and startup partners, as we feel this is a good opportunity to try out different solutions in the Living Lab. So these are the objectives of the Living Lab. So the first one is that research on IoT for smart cities. So there are several research works going on IoT for smart city at IIIT. And the Living Lab will give us good deployment insights and learning for our research. Second is the that data for AML. So already IIIT is well known for its AML research. Living Lab will generate huge amount of data. So this will help us create AI/ML models, algorithms, and application for smart city. Third is that the Living Lab will be a test bed for smart city deployment. So any company or startup can actually come and deploy the solutions in this controlled environment of decent size. Once successful, they can then take this to the city level deployment. Fourth is the last but not the least, one of the main objectives is also to promote startups in the space of smart cities. With 2 incubators and 250 startups, the Living Lab is a good place for startups in the smart city domain. So these are the themes in the Living Lab. So water monitoring, distribution, waste management, safety and security, health and energy. And here on the right hand side, we have sub themes, and these are again indicative. And these are basically themes for everybody, like for IIIT as well as the IIIT partners who will be working in the Living Lab. So specific themes which we have targeted at IIIT for research are this. Again, water monitoring, the 4 of them, and we are starting our research on these topics like water monitoring, water flow and quality monitoring, then crowd monitoring, air pollution and weather, building energy efficiency, solar energy, smart rooms. And this is basically the implementation of, this is the general architecture of the implementation of our Living Lab. So different nodes of different basically applications will be sending data to this 1 M2M server, and which will basically send data to the IUDX, which is the India Urban Data Exchange. From here, any third party can collect data and build applications on top of it. Then the data is also going to a dashboard from the 1 M2M server. I want to highlight a few points here, important points here. First is that we are deploying almost around 300 nodes currently in the campus across different verticals. So 100 nodes are just on the energy. Then we have water quality, we have 25, water quantity, we have 20. Pollution, we already deployed 10 inside the campus, and 40 we are deploying around basically IIIT. And again, smart room are going to be huge numbers. So already you can see that it's a huge number of nodes which are deployed. And one more thing is that we are trying different technologies. So for our research purpose, so you can see the different communication technologies like Wi-Fi, 4G, LoRaWAN, even the wired ones. So second thing is that the 1 M2M is a global standard, basically that covers requirements, architectures, API specifications, and interoperability for IoT technologies. Currently, we are using this OM2M implementation, which is an open source implementation developed by LAST CNRS and their collaborators. So third thing is that IODX is an initiative by Indian Smart City, Ministry of Housing and Urban Affairs and ISC to create a data exchange platform and also create unified data models for Indian smart cities. So as such, we needed to make sure that our data models are also in line with IUDX so that our work is relevant for the Indian smart cities. As a result, we started working with IUDX now. We are creating a 1 M2M and IUDX interface, as well as we are also participating in the discussions related to building data models for Indian smart cities. So I'm almost towards the end of my presentation. I just want to make some announcements that we would be looking for basically researchers, PhD, MS, dual degree, honors, interns, very actively. This is a new center and a lot of new problem statements are there. Very exciting problem statements are there. I also want to again invite industry and startups to come and participate in our Living Lab. There are also challenges and hackathons. So the challenge is the water challenge. Already the last date is 16th of March. And this has been, the problem statement has been given by Government of Telangana and National Institute of Urban Management. One more interesting news or exciting news is that IIIT, along with Talent Spring, is going to conduct this PG certificate in IoT and smart analytics. So this is my last slide. So I'm leaving you with the dashboard, and you can actually visit the dashboard at this web link. And the vision of the center is to be one of the best centers in smart city ICT research. And again, for collaboration, do write to us at this email ID. Thank you very much for this opportunity. Thank you.
Thank you, Sachin. Thank you, all the speakers. So now I request Aftab to explain how the showcase can be viewed.
Thank you, sir. Thank you all for joining us this morning. So we have created this virtual R&D showcase portal, which basically provides information. The landing page itself provides information about IIIT and various engagement models and information about admissions and everything. And if you look at the actual expo hall where the R&D showcase has been presented, we can actually go in and see all the research centers that are part of IIIT Hyderabad. They're actually listed there. Any of the research centers can be, when they are clicked, we can see all the list of all the projects that the research centers are showcasing. And pertaining to all the projects, we have information like there is a poster associated with them in high-res PDF, and there is also a video describing that project in detail. And we have some text description of the project as well. So I invite everybody to view all of the projects that we are trying to showcase through this virtual portal. Thank you so much for joining us this morning. Thank you.
Thank you, Aftab, and request everybody to view the showcase. So let me thank all the people who worked behind in making this happen, especially Professor Ramesh, Aftab, the team from Outreach and Communication, and others who are in the back. So with this, we'll end this session now, and please continue watching the showcase. Thank you.